Once again, welcome to yet another lesson of A-Level Physics Paper 2. I'm teacher course of Back Science Education Consultants. Quite often, we use many electrical appliances, but actually, some of the things used there, we may not know them. Remember the previous lesson about electrostatics, which is the study of charges at rest. The study of charges at rest. But how do you store those charges? How can you ensure that the charges that you have acquired, yes, we were seeing how you can charge maybe some metallic thing and you give it positive charges or negative charges. So where do you store them for some other future use? We have a device that we use to store such charges, and the device is called a capacitor. When there are more, they are called capacitors. So then what is a capacitor? You could even be raising your hand to say that it is a device that is used to store electrical charge, because I have just said it, and that is it. So therefore, a capacitor is an electrical device used to store charge in a circuit. I say a capacitor is an electrical device used to store charge in a circuit. We have not seen a capacitor before. We have seen resistors, whatever, but the capacitors in the lower levels, I know we have not seen them. Okay? How is a capacitor represented then? A capacitor is represented as this. And these two are what represent the plates of the capacitor, which are called the capacitor plates, because ideally they are plates. It is not just a line. They are plates. One will store a positive charge, another one will store a negative charge, but those two charges will be of the same magnitude. We are seeing another new term in capacitors that will help us give us a bigger increase what we shall call the capacitance of that capacitor. We are also going to look at that. That's what I can say. The working power of a capacitor is the capacitance. Okay? So something that is a non-metal that is called a dielectric. That is, it is called a dielectric. So therefore, what is a dielectric? This dielectric is a non-conductor that is inserted between the plates of the capacitor in order to increase the power of the working of the capacitor. That is to increase the capacitance of that capacitor. And therefore, when you come to a diagram, we shall now always have a dielectric placed between the plates of the capacitor. What is its role? You can see it is insulating the capacitor plates against one another, because if this is storing a positive charge and this one is storing negative charge, there is a lot of attraction. There could be a breaking of the air insulation here, and then this one is connected the other side. It's like when you have the gate to the hostels of girls broken. Boys may go there and of course girls will be trying to invite them there. So you have to put something that is strong, a strong fence. Okay? This case is what? Is a dielectric. That is the strong fence to insulate against each other. And after insulating, then it will ensure a high capacitance. When you stop those girls from mixing with boys, they have enough time for their academics. And therefore, at the end, you will have good marks, good performance. Therefore, the capacitance also, which is the performance of the capacitor, will be raised and it will be high. So, a dielectric material is a material which doesn't possess conductible charges. Those are the free charges. They are not free. It's a material that does not possess conductible charges and can withstand a high electric field intensity before conducting. I said it's a material which doesn't possess free charges and can withstand high electric field intensity before conducting. There will be too much of the intensity between these, because if this is positive and this is negative, then there is a field intensity. But we are saying once you have now that dielectric that can withstand too much of E, you have that fence that will withstand too much of pressure from both sides, plus that askari who is strong, cannot be corrupted by one of those notorious boys, then the effectiveness will be higher and the performance will be great. Okay? So then I talked about the uses of this. It is used to separate them, and then it ensures there is high electric field intensity that can be applied before insulation is broken, and then it is also used to increase the capacitance of the capacitor. So I have talked about 3 uses of a dielectric. 1, it is to insulate. 2, it will increase the capacitance of the what? Of the capacitor. 3, it ensures that there is no breaking of the insulation by a high electric field intensity. In other words, it ensures that insulation is not broken. Now, how do you now choose a good material for a dielectric? Yes. Remember, by the way, you can give me a point. Give me a point there. You say it, please. Yeah, I know you are watching either on YouTube or from one of your gadgets, but you just give me the answer. Say it. If you are watching with a friend, tell that person, tell him or her, what is that property that you think that surely an electric material should be having? We say it should be able to withstand high electric field intensity before breaking, meaning it should be an insulator. And then, you see, when you are to choose an askari to be put on that kind of face, or the gate from this side, the other side, I have been talking about it, you must be having a high level of integrity, not to be corrupted, not to be confused. And therefore, also our material should be having a high level of integrity. In this case, we call it a dielectric constant. Yes, so that material should be having a high level of a dielectric constant. Thank you for following us at BAC, BSc. Some people confuse it. It is BSc. BAC, BSc, Science Education Consultants. It is the source of understanding, and when you have good teachers, then you cannot fail to understand. That is automatic, and that one is only found at BAC Science Education Consultants. So please, if you have subscribed to our channel, thank you very much. Share, continue liking our videos, and continue watching them and encouraging others. Please share on all the social media platforms so that you can have as many students as you can
following our lesson so that we have a bigger number that is benefiting from our sacrifice. We want to see how, as we said, they are used to store charge. So now, how can you show that a capacitor stores charge? We want to put a capacitor in a circuit, and then we show that, oh yes, the capacitor can store charge. Can show that the capacitor can store charge. So experiment show that capacitors store charge. Yes. So how do we do that? We are going to have such kind of a circuit. We shall have, this is a DC supply. We know this one. Then we are going to have a kind of what we are calling some kind of a double switch here. Okay. So I have a capacitor here. This is a resistor. This is an ammeter. And then you can have our circuit completed like that. And just have that. And then we saw. Now, what happens? We can have maybe this, call it position X, and this one call it position Y. So what happens when this one touches here? Let me put this one. When this switch, maybe I call it switch K, we are using of that one. When this switch K touches at position X, what happens? This capacitor will be charged, because this is the positive side, this is the negative side, and the circuit will be complete. Okay? So when it is charged, what shall you see? You are going to see current increasing as read by that ammeter. Okay? Current increase, and then afterwards it will become zero. That is when the capacitor will have free charge. The current will no longer be flowing. Okay? And then what happens? We want to put this switch K to Y. We want to put the switch K to Y. What happens? So when this one is connected at Y, you see how you have disconnected this one from the supply, and now since this one will be positive recharge, will be negative recharge. So now the two will be connected and they will discharge each other. Okay? So you see the same diffraction as shown by the ammeter, but it will be maximum, and then but this time in the opposite direction. After which it will again go to zero. That is when the capacitor will be discharging. That means that initially this capacitor had stored charge, and then after the capacitor is discharging. Therefore, that one shows that the capacitor stores charge. We can say that when switch K is connected to position X, the sensitive current ammeter A, this one, shows a maximum diffraction, which then reduces to zero after a short time, during which the capacitor is charging. The switch K is then connected to Y. The current ammeter A is observed to show the same maximum diffraction, but which is opposite, which also reduces to zero in a short time as the capacitor discharges. This second diffraction confirms that the capacitor had initially stored charge. Now we want to look at the charging and discharging processes of a capacitor.
Then when we are done with those ones, we may end for this lesson, and then prepare for another, the charging process. So, how do you charge a capacitor? Yeah, you have those two plates. So, how do you charge a capacitor? That's as simple as that. How do you charge a capacitor? You just get your capacitor, arrange it. You have this diagram. You can have a resistor. It's protective. You can have your ammeter there. So now, what happens? We can name these two plates. We say this is the plate X and this is the plate Y. So what happens when you connect these ones? When you just connect them like this, somebody can decide to put a switch here. Okay? And say this is the switch K. Let's just say that one. Okay? So when the switch K is closed, what happens? This is the DC supply. Okay? This is the negative terminal. This is the positive. So these negatives will be wanting to go to this, but they can't pass here. So the negative electrons, the negative charges, will flow from here and then will pile on this plate. Meaning this plate X will become negatively charged. And as they pile on this one, there will be negative charges which also attracted this positive one here. So the negative charges from within this plate, because you know any atom, any neutral atom has equal negative and equal positive charges. So meaning when negative charges leave this one, they will leave their excess positive charges. So negative charges will leave this one as they go, as also negative charges, or as the electrons, as they leave this plate, we shall remain with the excess of positive charges. So therefore, this one, this plate Y is charged positive, and this plate X is charged negative. That is simply the process of charging of a capacitor. I could simply talk about discharging because it is as simple as, how do I discharge? Yes, the capacitor had charging. How do you discharge that capacitor? The discharging process. So the discharging process of a capacitor is simply as you remove the battery, okay? You remove the DC supply, and then you connect these two wires. As simple as you have the capacitor plates. One was positively charged, another one negatively charged. The resistor may remain there. So you just connect the wires. You just connect the wires. The moment you connect the wires, these negatives will flow, and will finally come here. So they will come here and neutralize these positive ones, and you remain with the plates of the capacitor which are not charged. That is simply the charging and discharging process of a capacitor. Then we shall, when we come back, we are going to look at some of the things that actually happen when we are charging and when we are discharging. Allow me, I stop at that point, and to just remind you of what we looked at, that a capacitor is a device that is used to store electrical charge in a circuit. For a capacitor to work very well, you need a dielectric, which is an insulator, and that dielectric can be paraffin, can be waxed paper, can be mica, can be an electrolyte, can be air. It can be any of those ones, okay? And then we saw the uses of a dielectric, used to insulate, used to increase the capacitance, to ensure high field is applied before the insulation is broken. We saw that the capacitor stores charge by doing some practical there, some experiment, and we show the charging and the discharging. The charging is still here. You just connect like this. Then when you close the switch, when you close it, the electrons will flow from negative, will come and pile up here. As other negatives are running away from these ones, they will go. As they go, they leave excess positive charges here. Then as you discharge, you just remove the battery and connect these wires. The negatives will flow and will come and neutralize these ones, and you'll have your capacitors discharged. Thank you very much for following us. Thank you very much for watching our lessons. Thank you very much for studying with us. I still encourage you. The sky will will not even be the limit. This is BAC Science Education Consultants, and I'm Teacher Course. All the lessons are here. Please don't forget to share. Don't forget to remind friends to subscribe as you follow our lessons. And feel free to contact us in case of any question. We are available for you. That is it for now. Be blessed and stay blessed and go and bless others.